let me continue on the numerical integration. Numerical integration. But before that, please subscribe my channel and watch online my videos. I told some formula when we had in fact 1 point or 2 points at the nodal point in the numerical integration. In case 3, let we have x0 and f of x0, x1 and f of x1, x2 and f of x2 as nodal points. Okay, what we want to do, I want to compute the coefficient of the integral f of x d of x be equal to alpha 0 f0 plus alpha 1 f1 plus alpha 2 f2, and I want this formula be accurate of order number 2. So in fact this formula should be equal. The equality should hold for f of x equal to 1, f of x equal to x, and f of x equal to x squared. Okay, so I write this formula should be accurate for f of x equal to 1, f of x equal to x, and f of x equal to x squared. Okay, now let x0 be equal to a, x1 be equal to a plus h, and x2 be equal to a plus 2h equal to b. So this implies that h is equal to b minus a over 2. Okay, so if I consider these points x0, x1 and x2 to this form, and I consider h equal to b minus a over 2, so we have to have 3 equations with 3 unknowns. The first one is integral from a to b. Put instead of f function equal to 1 dot d of x be equal to alpha 0, so I should have dot 1 plus alpha 1 dot 1 plus alpha 2 dot 1, because if I have this as f of x, so f of x0 is 1, f of x1 is 1, and f of x2 also is 1. So this gives the first equation. What's the first equation? The first equation is b minus a, or let me write in different form, alpha 0 plus alpha 1 plus alpha 2 is equal to b minus a. Okay, this formula should be accurate for x, d of x. So this should be alpha 0 x0 plus alpha 1 x1 plus alpha 2 x2, and this gives, here I rewrite alpha 0 x0 plus alpha 1 x1 plus alpha 2 x2, and the left hand side should be half times b squared minus a squared. Okay, and for the last one I should put instead of f x squared d of x, and this should be alpha 0 x0 squared plus alpha 1 x1 squared plus alpha 2 x2 squared, and this gives alpha 0 x 0 squared plus alpha 1 x 1 squared plus alpha 2 x 2 squared, and this should be equal to 1 over 3 b cube minus a cube. Okay, so in fact I have this system of equation. This system of equation has three, in fact, unknown with three equations. Okay, if you put instead of x0, x1 and x2 from here a plus h and a plus 2h, or b in fact, so you will get a system like this. So in fact this system of equations gives a new one. What's the new one? This is alpha 0 plus alpha 1 plus alpha 2 is b minus a, no change. But here I will have alpha 0a plus alpha 1 times, put instead of x1, a plus h plus alpha 2b equal to half b squared minus a squared, and also here alpha 0 a squared plus alpha 1 a plus h squared plus alpha 2 b squared is 1/3 b cube minus a cube. Okay, so we have to solve this system of equation, and it's not difficult. You can do it easily, and if you do it you can find some values for the unknown parameters. Alpha 0 equal to h half h over 3, alpha 1 is 4h over 3, and alpha 2 is equal to h over 3. So if you put these coefficients in this formula, you will get h over 3 times f0 plus 4 f1 plus f2 plus error, in fact. Okay, so you can get formula like this. A to b is of integral a to b of f of x d of x is equal to h over 3 times f0 plus 4 f1 plus f2 plus e, and I told in the previous lecture this is error. Okay, I will talk a little about this later. Okay, so this formula is called Simpson method, and note that here h is b minus a over 2. It's not just b minus a. Okay, this formula is called Simpson method. Okay, this is Simpson methods. Now let me solve an example, and I compute an integral, the exact value and the value of the integral for different techniques. Okay, let me write an example here. Example. What do we want? I want to compute integral 0 to half square root 1 plus x d of x. Okay, we know that the exact value of 0 to half square root 1 over x, 1 plus x d of x is 2 over 3, 1 over x to power of 2, 3 over 2, 3 over 2 from 0 to half, and it will be 0.55807. This is exact. Exact value. Okay, let me keep it. This is exact value. Now, let me start and compute the value of this integral with some, in fact, the other method. First of all, the rectangular method. Now, let me compute by rectangular method. Rectangular method. What was the rectangular method? The rectangular method was something like this. A to B, f of x, d of x is equal to b minus a, okay, times f of x 0. Okay, now if I let x0 be equal to 0, so b minus a is equal to half. Okay, b minus a is equal to half, and this integral from a to b square root 1 over x d of x is equal to b minus a. It means half times f of 0. Okay, and this value is half square root 1 plus 0, and this is half, and this will be 0.5. You can see that this value, this estimated value with the exact value has an error about 0.05 almost. Okay, and it's not very accurate. Now let me try the other one, I mean the trapezoidal technique. Trapezoidal. What was the trapezoidal? It's from A to B. F of x, d of x is equal to h over 2 times f0 plus f1. So here we have to consider h equal to, in fact, a equal to 0, b equal to half, and h equal to half. Okay, so if I put these values in this formula, I will get integral from 0 to half square root 1 plus x d of x is equal to h is half over 2 is 1 over 4 times f0. f0 means this is f, in fact. Square root 1 plus 0 is 1 plus, and 1 plus 1 half. It will be in fact square root 3 over 2, right? Something like this. And if you compute this value, it will be 0.55618. Compare this value with the exact value, you have the accuracy of in fact 0.001. Okay, in fact 2 digits after the decimal point is accurate. Now let me continue and try to find the value with Simpson formula. Okay, and the last one, Simpson. The Simpson formula was in this form. A to b, f of x is equal to h over 3 times f0 plus 4, f1 plus f2. Okay, where h is 1 over 2, yeah, h is 1 over 4, h is 1 over 4, b is equal to half, and a equal to 0. So the middle point, in fact x1 should be the point between 0 and 1/2. It 1 over 4. Okay, so let me continue to compute integral from 0 to half 1 over x square root d of x is equal to h is 1 over 4 over 3 is 1 over 12. F0, put 0 here, it's 1. Put 1 half here, 4 times square root 5 over 4, and plus put half here, square root 3 over 2. And if you compute this value, it will be 0.55807. And if you compare this value with this value, you will get you will find out that this value is more accurate than this one, because this is exactly with in fact 5 decimal point is equal with the exact solution. Okay, so this is the in fact the 3 simple method. But the big problem appears when we want to increase the accuracy of the numerical method. Okay, one idea is that you increase the number of nodal points. For example, you consider x0, f0, and x1, f1. So finally we get x0, n, f, n. In these cases, the formula should be accurate up to order n. Okay, so we will get a system of equation with n plus 1 equations and n plus 1 unknowns, and it's not easy to compute the unknown coefficients. Okay, so this is not easy, and in fact this technique we have to forget about these techniques. If we want to do something easier, we can use the Lagrange interpolating polynomial to compute the values. And let me start these topics in the next lecture, and let me finish this lecture at this moment. Please subscribe my channel and please watch my videos online. Thank you, and wait for the next lecture.